Hanji, so Assalamualaikum. So last time we in the theory class we found the DH table. We derived the DH table of a robot. So now we are going to analyze. We are going to use the DH table to find the powered kinematic model of the robot. Okay? So this is how we do it. So let me put the objective. Given the to find or determine the forward kinematic model of a robot using the DH convention. So before I do that, let me add one thing to the notes. I mean, to what we did in the class. We reached up till here. So let's find a way to understand how to get, like we already assigned the frames here, and that's how we reached at the DH table. Now let's say I want to simulate this robot in the robotic toolbox. Okay, so this is to animate or to simulate a given robot in MATLAB robotic toolbox. So in order to understand that, first we need to see any other robot that has already been simulated. So for that, what I'll do is, if you go into the robot folder and anything that you see that starts with MDL, these are simulated robots. So let me repeat. So let me open this. You go outside by presenting, please. Yep. Thank you. You go inside the robots folder. That's what I'm highlighting here. Whatever is the path to your robotic toolbox, make sure you're inside that. And then the files that you see here, they start with MDL, and there are quite a few. So everything that you see here with the MDL, these are simulated files. So this is in the procedure. Okay, so let me delete this one. Yeah. So browse to the robot folder in your robotic toolbox. Any file name that starts with MDL is actually a simulated robot. So you can clearly see that. Here, my diagram has copied. Oh. Yeah. So make sure you're there. And now let's understand any one of these. So that would be the best way to start. And then in future, we should be able to write one of our own for a robot that is let's say not there. Okay. So yeah. So let's open any one of these. For example, let's open one which is already there in the robotic visualization software. I think Fanuc was there. Or maybe this UR is a very well behaved robot. UR10 if they have it. Or UR5. Okay, what's the number? And no, it's not there. Okay, it's not there. It's one of the most famous. Okay, Kumastani, let's take IRB. This. Okay. So if you open this file, if you double click on this creates a model of this manipulator. Okay. IRB and B140. So we'll understand its pH table once we see the robot. So it looks like this. I want to see a complete robot. So it's not here, maybe in the data, not in the manual, but it will be in the data sheet. Controller pH table. Oh, it's not here. Okay, no worries. Yeah, but we can find it from here as well. So let's see. These are the D's. So D1, sorry, D1, A1, A2, D4, D6. So these are the link offsets and these are the link lengths. They are coming from the data sheet, but somehow I cannot find the data sheet. Okay, let's find it here. Okay, this one, it's too tiny. Yeah, maybe this one. So let's compare it with the MATLAB file. They say the word D1 is 0.352, which is 0.475. It's okay. This one is in mm, this one is in meter, but still there is a little difference. It's okay. D2 is 0, D3 is 0, D4 is 720, D4 is 380. Yeah, so, and D6 is this, so I wouldn't trust this one. Let's look at the A's. A is 0.15 A1, but here A1 is 0. Yeah, so let's not use that one. Yeah, so there is one. Let's now open this. 3752. Yeah, D1. D2 is 0 because it's not there. Even if you initialize it, it doesn't matter. D3 is 0, D4 is 380. Yeah, so it's in meter here. And D6 is 0.065. Actually, the reason D6 is 0 here is there might be a tool attached here. So we'll see that. It's okay. अक्सर D6 के आगे remember ये जो आपका D5 था उस केस में D6 है, but this is close to it. Let's look at the A's. A1 is 70 millimeter, so this is 0.07, and A2 is 360, it's 0.360, so that's good. These are lengths. Then the DH table has been constructed here. It's you can find it in the exact, yeah, so 0. What is 0? Your theta is 0. You have to put it in some 0 configuration. So all the thetas are 0. Okay, theta 1, theta 2, theta 3, theta 4, theta 5, theta 6. D1 is not 0, D4 is not 0, and D6, and the values have been initialized already up there. Similarly, A1 and A2 are not 0. Okay. Acha. And this one is A0 actually, and alpha naught. Okay. So इस रोबोट के काइनेमेटिक मॉडल को पहले थोड़ा समझना होगा कि इसका a, yeah, there is no a naught anyway. A1 is along x1. ठीक है. That's the same case as we had. A1 is along, yeah, A1 was 0 in our case, A2 was along x1. So थोड़ा सा हमारी इनकी कन्वेंशन डिफरेंट है. जिसको हमने A1 कहा था, इन्होंने उसको A naught का हुआ, because when I is 1, 1 minus 1 is 0. So this is A naught actually. For them it's A naught, for us it's A1. For them this one is A1, for us it's A2. We just simply name everything according to the excess number, but they just make it I minus 1. And our A was like this. Yeah, this was our AI. We didn't call it AI minus 1. So इस चीज का ख्याल रहे, लेकिन why don't we just take this robot and put it there? Let's see what happens. Okay, so but before, let's understand the file structure in the MATLAB. So whatever was that, bring your A's, A1, A2, and then the rest of the A's are 0, and then alphas are minus pi by 2, okay, and 0, minus pi by, okay, here again. So yeah, so our DH table is not even from here. He must have given a reference to where he picked this from. It's IRB 140 manipulator. Oh yeah, he took it from the data sheet. So let's go there and find it. So this seemed like a data sheet. And if we look at the DH parameters, they're not directly given, but it must be scattered here. So let's take us another simpler robot in which we can directly match our. Why don't we simulate the same robot that we did in the class? So how would we do it? Let's do it like this. You just need to change these values. बल्कि सबसे पहले, instead of writing this file of our own, let me tell you how to use it. But I just want to make sure that this robot's, yeah, DH parameters are given. So Fanuc 10, this is Fanu, this robot. I'm trying to pull out the data sheet, and let's see. Well, this is mostly done in the robotic toolboxes. I'm gonna find the one which is from the company 120B10L. Please अपना microphone mute करें. So, okay, let's look at this guy. And if you remember, we saw this in the robot visualization software too. So, इसके DH table अगर given हो, ठीक है. If not, then we can just trust their DH table. Yeah. So these are the workspaces. DH table is not given, but let me explain it. How? Let's understand this format. So link is the object. We'll create each link in MATLAB. So if there are 6 degrees of freedom, we'll give link command 6 times. And every time we will store it in one of the element of the L class. Okay, so we are creating a 6 by 1 vector. जिसमें से पहला element is this link, second element in MATLAB. देखिए MATLAB में हम क्या करते हैं कि if you want to have a 3 by 1 vector, let's say, तो एक तरीका ये है कि you just write it 3, 2, 1. This is one way to do it. दूसरा तरीका ये है कि let's say b of 1 is 3, b of 2 is 2, b of 3 is 1. If you look now at d, it's the same, okay, except that we put it in a row form and that was in the column form. So it doesn't matter, we can transpose it. But similarly, we're creating different link objects, okay, software mein. And every link has these 4 parameters. So first we have to give theta. Then the second one, it expects from you is whatever your value of d is. The third one, they expect from you is the value of a1, and alpha 1. And this is just an offset, it's always 0. And then theta, 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 all 0. And d1, d2, d3, d4, d6, a1, a2, a3, and this, and these are alphas. And once you have this L, now you also initialize a home configuration. Remember I told you a home configuration is the one in which you have put the robot, like this one, okay? So let's call it Q0. I can have as many configuration as possible. For example, my other configuration will be, I'll just copy this and I can call it my Q1. And this one, instead of plus pi, minus pi, it will be plus pi, and I can even make this one pi by 4. So these are different joint angles that I'm given. And then the next object is, name it a serial link. It's a MATLAB Robotics Toolbox command, and give it that L object that you have initialized up there. And L has 6 link objects in turn, okay, in software. And together the serial link, whatever it returns at, this now represents our robot. And you can even name it as Fanuc or name it as ABC. You give it the name and then specify any name. So how to use that? Let's see now. So first of all, just press run. So when you run it, now look at the workspace. There is nothing. Okay, it gives error. Is not found in the current folder. RC1, yeah. Okay, so what's wrong? Error in this. If I run it, no, it's not working. Did I run RVC? No. Let's try to run it again. Yeah. So now let's go back to there and just it's open here. So now click on this. Yeah, now it works. How do I know? I got a no error message and I got this L object there, which is 1/6. Okay. Even if you press L here, if you write L here, these are all your links. This was the first link that you created. How did you create? Like this. This is the second link that you created. Third, fourth, fifth, and so on. So that's your L object. And what is your R object? R object is whatever was your L, you give it to the serial link command and it returned an R object. So if you want to see your R object, just type it and enter. So now let's understand what it returns. It returns whatever you name the robot. Whatever you name the robot. It's here. And it automatically came to know that it's a 6-axis because you give 6L. And it knows that R, each of the joint is a revolute joint. So 6 R's, R, 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 R. And it's a standard DH convention that we are using. And this one, we didn't specify, but automatically it's for dynamic model. We'll see this in future. And then it displayed the DH table for you. Okay. So, and then it is telling us that the base frame is this, which means that your X is normally whatever your X in the real world are. Okay. And tool frame initially is this. And gravity is pointing along the z-axis. That means your robot is somewhat in this configuration. So X is to the right, the unit vector is 100. Unit vector is 100. Y is upward, sorry, into the page, and Z is upward. And gravity is along the Z-axis, 9.81. Okay, so this is my robot. Now the next is, what I'll do is I'll give you a chance to execute this command. What I picked the Canoe one. Okay, so on the, make sure you are inside this, yeah, you're already in that folder. And on the MATLAB command, just type Canoe 10L. So when you do that, so on the left, if you look, the important command that the change in the workspace, the workspace that you should notice is you have these two objects. One is this, and one is this. And even my Q0 and Q1 are also there. Okay. So this I can clearly say that this is my link object. Okay, software object. And these are my robot object. You can name it A, B, C, or R or something. It's not that strict. So this was given. And now if I want to see my links, just type L and it returns this. Okay. And if you want to see your robot object, so which is R, just press R and you whatever you see is that command returns them. Okay, so this is your, so well, it's a little scrambled, but it's okay. So make it Look good. Yeah. So these are your, this is your DH table. Yeah. And now what we want to see is we want to plot the robot. Okay, so for plotting, next is to plot the robot. So how we do that? For that, the command is take the object name, which is R dot, and type plot. And if you type PL and press a tab button on the keyboard, it can give you all the possible commands. So just in case you don't know the complete command, it can give you the plot command. And what you want to plot, we're plotting Q0. We got two Qs here. Let's plot Q0 and press enter. So it's taking some time, it's busy. So let's wait for it, and then we're this. So note plot the next is to plot the robot in a given configuration. For example, Q0, and Q0 was initialized as it is given here, otherwise it is in the file. It's this. This is a certain configuration. And now our plot is there. Yeah, looks pretty little weird, but don't worry. So you can play with it by just holding your left mouse button and bringing it inside. Okay, so this is, make sure you get something like this. That's the output of for the command. And now let's understand it, how it works. So what I need to see is I want to find the orientation of the tool frame for which X is pointing upward, okay, Y is pointing into the page. So where will be Z? X is your index finger, Y is into the page. So Z is there. Wow, it's quite interesting. The Z has rotated all the way towards this. So let's put it in a different configuration, and that is what I do is I'll plot it in Q1. Yeah. So X is there, Y is upward. Y? Z is pretty funny. Z is pointing this way. So why is this? Okay, so let's change Z. These are road pitch yaw angles, the last one. So let's make this guy minus pi by 2. Or instead of 0, let's do it pi by 2. Okay, and now plot again. Oh, sorry. इसको initialize करें फिर से. Evaluate selection. Now this is my Q1. And now if you plot, yeah. So X is upward, Y is towards you. So Z has not changed again. This is pretty funny. Let's make this one. And now plot it. Okay, so nothing has changed. So anyway, instead of understanding that, let's do something. What will, how in my, oh yeah, where is the base frame, by the way? So the base frame, if you can see here, the base frame is at the bottom of it here. And here, oh, sorry. Let's close it and plot again. So the base frame is here. Y is 0. Okay. X is 0. Look at this. This is X frame, so 0. Y is 0. And Z is, if you look at the robot, किसी का microphone on है जी, बड़ा तंग कर रहा है. So this is your Z. Z is 0 here. Okay, so that is my Z. I can clearly see that at this point, that is my Z, and Y is 0, X is 0. So I want to find the orientation of the end effector relative to that. So let's go into the book. We did till here, and just write the forward kinematics. FKINE. R dot FKINE, and give it that Q1 in which you have plotted the robot. So let's say what it gives me this. So how to interpret it? So it tells me that the tool X is pointing along the Z-axis. The tool X is pointing, X is upward. It's pointing the global Z. Yeah, so Z is upward. I can clearly see from here. And it tells me that the tool Y-axis, because this column is for Y-axis, the tool Y-axis is along negative Y. So Y is towards you, and this is actually negative Y, if you can clearly see from here. Okay, this is good. So positive Y is that way, negative Y is this way. And the third one says this is the, sorry. So the tool is here, and I'm minus 0.91. So let me take a screenshot like this. And this distance is from here, from origin 0 to here, tool frame. Okay, this is the original. These guys meet there. I can show you that this is my, oh yeah, I can overwrite this. Let's not do that. Yeah. So this is the minus 0.1, this distance. Or this is the tool frame, yeah, along X. Okay. Similarly, Y is perfectly aligned along the Y, so there's no distance that the origin is traveling along Y. It's just at 0. And Z is minus 0.87. So for Z, we have to put it in a different plane. Let me pull this and put this here. And in order to visualize Z, we need to look at it from in a different plane. So let's say X is Z. Yeah. Along Z, we are minus, minus 0.87. Oh yeah, it's pretty funny because 0 यहाँ पे, हाँ yes, minus 0.5 ये है, तो minus 0.87 है this. So if I take the I can take the screenshot again. Okay, so this is telling me that this distance from the origin to the tool frame along Z is minus 0.87. This one. Okay, So थोड़ा सा messy नजर आ रहा है, but you can understand that. This is another one. So इसके caption में मैं लिखूंगा x component of the position vector. Position of who? Of the tool frame. Position of the tool position vector. And this one is the z component of the tool position vector. Okay, so that means that the forward kinematic problem has been solved. It does not give you those equations or anything. It just gives you the end effector. Now the interesting thing is if you put the robot in a different configuration. So what I can do is the first task is, okay, so the first task is this. Find the forward kinematics. Find the tool pose, which means position and orientation for a different configuration, which is, just take anyone. Let me take it randomly, Q3. And that is, let's say this one is pi minus pi, pi तो हाँ 180 होगा, ठीक है, minus pi by 2, pi by 3 or pi by 4, 0, 0, and pi by 3. So let's say this is this pose, and your job is to find the end effector that for this. Okay, this is number one. Number two is, okay, repeat. Did we mention somewhere that this was Fanu? Yeah, it was mentioned here. So let's say we take another one. Take a different robot, such as IRB 140, and find the tool pose for a given, for some given configurations. ठीक है, तो उसके लिए फिर आपने अभी डिफरेंट लेना होगा, ठीक है। और लास्ट टास्क जो अभी मैं करने जा रहा हूँ वो ये है कि भाई repeat the same for the example robot done in class. जो robot है उसका नाम है माइक्रोबॉट। वो कैसे होगा वो मैं भी आपको बताता हूँ, ठीक है। अभी टास्क आपकी तरफ आ रहा है, लेकिन पहले अगर मैं इसी फाइल को लेके कॉपी बना दूँ इसकी, let's say I name it as file save as, और मैं अपना नाम दूँ इसको, let's say MDL microbot. I hope it's not already there. No, it's not there. And then ये ऊपर तो कमेंट्स हैं वो इतने क्रूशल नहीं है, आप लिख सकते हैं कि भाई microbot creates kinematic model of the microbot robot. Robot, बाकी चीजें खैर है हटा दें। So Q0 हम ले लेंगे कोई होम पोजीशन, इसको डिलीट कर दें। Notes, SI units are used. Author is your name and your class number. Copyrights चले रहने देते हैं, और the rest is वो भी छोड़ दें। तो अब हम जनाब क्या करेंगे? We have our theta. Yeah, so now open your book and just DH table को इसमें इसके मुताबिक इसमें changes लाएं. So theta 1, D1 is 0.215, sorry, 0.215. This is in meters. A1 is 0 and alpha is minus pi by 2. So पहला तो ठीक. Second one is D is 0, A is 0.1778 and alpha is 0. Okay, and offset is also 0. Number 3 is D is again 0. This is again 0.1778 and this is 0. Okay, and this is also 0. So link number 4 is D is again 0. And link number 5 is A is 0 and A4 is minus pi by 2. And the last one is 0. No, it's not 0. D is 0.1295 and A is 0 and alpha is 0 and the offset is 0, and we don't have a 6 length, so this will be just deleted. So now you have a 5 degrees of freedom robot. This is your A, this is your alpha, and now give it a configuration of any known configuration. So verify करता चलूं फिर theory में इसको देख लेंगे. खैर है forward kinematics part 2 में I'm giving you a home configuration of this robot. Which is, yeah, 0 0 0 minus pi by 2 0. So इधर आके 0 0 0 minus pi by 2. अब चूंकि 5 degrees of freedom है तो 5 elements होंगे, ज्यादा नहीं हो सकते. आप इसके अलावा भी कोई ले लें, pi by 2 and 0 और ये आखिरी वाला डिलीट. So this is your another sample. Name इसका रखेंगे microbot and that's it. Save it. And now if you R का नाम भी आप change कर सकते हैं. Why don't you just name it microbot? So if you run it, so now your microbot object is here, just to the left. And now if you write microbot.plot, and पहले तो सिर्फ microbot लिख के enter दबाएं. So this DH table is exactly what we did in the class. और अब इसको plot करें given configuration Q0 में, तो robot का नाम dot plot Q0. So now this will give you the robot is like this. So no, I did not. So this is इधर गए. ये भी हम series के खैर फिर कर लेंगे. But this is what the robot is in. जिसमें Z is extending outward, X is extended upward, tool frame, no? And Y is towards U. So I can show you this as a procedure. में इसको डाल देंगे. Repeat the same for the example robot done in class, which I already did. So let's simulate the example robot microbot that we covered in theory class. So this is it, and changes were made to, please make a copy for this. Please write a new file, mdl microbot.m. That's a MATLAB script, and do changes accordingly, and change the DH table as per the one given in the lecture notes. Okay, so सारा कोड भी मैं इधर पेस्ट कर सकता हूँ, but it will become a little messy. Control A, Control C. Let's see how it looks like. Oh, it looks ugly. So I will say that this is the content of my file. And now when I go to the MATLAB, I just say, I run it. Okay, run the script. And the one way to run it is just write mdl microbot and then plot it. Microbot.plot q0. And that's what you get. Okay, and now the important thing is how to interpret these values. And if you look at the way the MATLAB plots the robot is pretty similar to what we did. So this cylinder represents here, the first joint is your, all the joints are revolute, but the first one is the axis of rotation is upward. Yeah, the node is upward. This one says that the axis of rotation is into the page. I mean, yeah. And this one is into the page. This one is into the page. And this Z was this, it's a roll, if you can see that cylinder lying down. And the tool is then there. The gripper is not shown, but it's okay. All we need is the tool frame visualized for us. So this is the, now we didn't find the forward kinematics, but it's pretty easy. The command is just microbot dot plot q0, no, forward kinematics, if kind q0, so it gives you this. Okay, so if I paste this here, so let's see how to interpret these values. Okay, this is a MATLAB command. So now let's interpret this. So the first one says that yeah, so this is my transformation matrix. So the origin is 0.48 along x. So you can clearly see that if you look into the xy plane, so the tool is 0.48 along the x, positive x. There's no distance covered along y. Okay, and along z, I have to look at it in the xz. It's I think 0.2. Yeah, it's here. And if you look at the orientation, so the tool x is pointing along positive z. So that's what I can clearly tell from this first column. And the tool y is pointing along negative y. Yeah, here. And the tool z is pointing along positive x. Yeah, so this is good. And now if you change the q, you can this. So what I say is repeat the same for how can we task on this? Sorry. ये में 17 भी तो छुट्टियां भी हैं 10 से, तो ये उसके बाद 21st. Okay. So the same for, we already did this. There is nothing left. But I remember I opened this. This guy did it quite well. Only thing is don't use the modified DH parameter. So he's giving modified here. You don't have to give modified here. So what we did was he used another way. He first writes that theta is this. Well, I don't need to give you those notes. But if he has done a good robot, oh yeah, then okay, so this will make it super interesting. If I give you this is a blue robot and this is a green robot. Oh yeah, this could be a good question in the exam. So for assign the frames. Remember the frame assignment was the hard part. It's a very complex geometry. क्योंकि joints बिल्कुल 90 degrees पे है, नहीं है 120 degrees and so on. But that's not a big deal. Let's look at this robot. It's pretty straightforward. Okay, let's look at this one. This is RRRT. So this is Revolute, 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 and T. T is this guy can move up. Okay, let's not make it more complicated. Let's stop here. So what we did today is we just, yeah, to determine the forward kinematic, yeah. So बल्कि determine हमने नहीं किया, forward को already analyze किया, ठीक है? To simulate a, yeah, and to solve the forward kinematic model for a given industrial robot, to understand the serial link command of the robotic toolbox. Not only serial link भी हमने किया, फिर serial link के through उस object को find किया, plot command को भी execute किया, and find को भी किया. So these are this. So let me give you this task. At least एक task आप इधर करेंगे. I want to see कि भाई how. थ्रस्कुन मयान अगर कोई खाता है तो फिर बस पार्टी करें ईद के बाद. अच्छा. So this one is, वैसे ये इसका ये वाला पार्ट मैं हटा दूं तो ये फाइल थोड़ा सा इसका ये वाला वो हटा देते. Yeah. So now it's quite manageable. अच्छा ये तो आपके साथ शेयर ही नहीं किया ना, कोई कह रहा है. मुझे तो लगता है आज कोई बहुत टाइट किस्म की नींद की है आप लोगों ने. So let's paste it there.
ये अपसेट के बारे में थोड़ा समझे, इसका क्या मकसद होता है? ये तो अभी तक हमने जितना लिया हर जगह पे जीरो होता है.
हाँ बस अभी फिलहाल छोड़ दें, अभी ये थ्योरी में आएगा तो फिर हम इधर यूज करेंगे. फिलहाल बस ऑफसेट 0 है. ठीक है, जहाँ से एक जॉइंट खत्म होता है वो दूसरा ओरिजिन उधर ही पड़ा, कोई ऑफसेट नहीं. तो फिलहाल मैटलैब के उस पर कमांड दें. अभी ये थ्योरी से मैंने थोड़ा सा पहले ये वाली थ्योरी भी नहीं दिखाई जो अगली क्लास में है कि भाई ये ए मैट्रिक्स. बाय द वे अगर इसमें इम्पोर्टेंट कमांड ये था कि मुझे टूल फ्रेम्स दे दे. या s1.t, s1. Yeah. So this is MDL 560, very famous robot. So it's could be serial link command के through, and plot command है, forward kinematics command है, and then base आपको given है. You can change the base, but we'll not change it for now. And Okay. Yeah, the rest is inverse kinematics. So we're not doing that for now. So इसमें मुझे क्या क्या command है मेरे पास microbot dot and if I can yeah, so this is what I was looking at. Animate में मुझे लगता है you can give I can just try देखते हैं कि ये काम करता है कि नहीं. So let's say I make a new queue which has Q0 and Q1. So उन दोनों को मैंने सिर्फ एक मैट्रिक्स में डाल दिया. I'm just doing it for my understanding. So microbot dot animate queue. So let's see if it moves. No, it did not move. Let's see. Okay, so it gives error. So let's leave this animate command for now and see it if I can cover in the next class. It makes it move. Okay, what I was interested in was microbot and press tab. So look at all the commands. So let's say Jacobian is something very important. We'll do it in future. Plot 3D are in yeah T1. No, T is empty. पहले ये देखना पड़ेगा कि इसका कंप्लीट फॉर्मेट क्या है. फर्स्ट आप लोग एक टास्क कर लें कम से कम कि मुझे मेक श्योर हो जाए कि यू कैन run the any of the MDL files. So what you're going to do is do the first task and show it to me. Okay, first task कर लें and let's see how many of you can do it.